Hello, SCADA troopers! I'm Nick Sobols, and I'm excited to take you on a journey to discover a great product I've been working with, VTScada, the industry's most powerful SCADA software. Although it's a relatively new addition to Delta Electronics' industrial automation portfolio, VTScada itself has been going strong for over 30 years. During that time, it has delivered reliable supervision, control, and data acquisition solutions across a huge range of industries, from water treatment and oil and gas to infrastructure, mining, and beyond. On VTScada.com, you'll find impressive features and real-world success stories. But in this series, I'm going to show you something even better, just how easy it is to build your own VTScada application and how much you can accomplish using the powerful standard tools included right out of the box. So buckle up and join me for the videos ahead. I promise it's going to be a ride worth taking. To begin our project, we launch VTScada, which opens the VTScada Application Manager, the central hub for creating and managing all applications. From this interface, you can immediately see key information about your license, the current software version, and the components it includes. You can also access essential settings. System languages are English, French, and Chinese. As a first step, we launch the Training Simulator. This purpose-built application provides a realistic data source for our project. It behaves just like a real PLC, allowing us to read and write data exactly as we would in a live industrial environment. Very useful tool for development and tests without needing any physical hardware. Once the training simulator is running, we simply minimize it and move on to creating our own application. By selecting Add Application, VTScada offers both a quick setup option and a set of advanced modes, such as opening an existing project, importing from a change-set file, or getting from another workstation in the network. We proceed with the standard option for a new application. We name it Opus and click Finish. In just a few seconds, our new VTScada application is up and running, ready to be configured as we will do. With new application launched, we are greeted by the standard page menu with several pre-configured system folders. We can open one of them, called Sample Pages, to enjoy a beautifully designed dashboard, perhaps the most iconic VTScada page of all time. It serves as an excellent source of inspiration, showcasing a wide range of graphical elements called widgets that are unlinked and must be connected to real text to become active. Alarms, Reports and Diagnostic folder contains several system pages. For example, the alarm page is currently blank, as no alarms have been created yet. The main control icons are located in the top right corner of the screen. The first icon opens Idea Studio to build the graphical interface. We will use it later. The small cogwheel icon opens application configuration, one of the most important areas of any VTScada project, where the majority of configuration settings are managed. You can immediately review basic settings, and in advanced mode you can access to hundreds of detailed configuration options. In addition, under Languages, you can easily add your own language, be it English, American, or Scottish on a bad day. All text and phrases can be exported, for example Excel, translated, and then re-imported back into application. The process is straightforward and very efficient for multilingual projects. Finally, the Tag icon opens the mighty Tag browser. In VTScada, every variable, page and widget is actually a tag. You can see that approximately 5,000 tags are already running by default. However, these are internal system tags and do not count toward your license tag limit. At the moment, only one license tag is used, and it comes from the training simulator we launched earlier. So, let's start creating tags for our application. Let's begin by creating a dedicated structure for our project. First, we create a new folder. Right-click, New Child, which means creating a new subordinate tag, and then we choose the context tag type. Let's name it Amsterdam. This will be the main container for all the tags in our project. To establish communication, we next configure a port. We again select New Child, Ports, TCP/IP, and name it Simulation Host. On the Connection tab, we enter the IP address 127.0.0.1 and port 501. This address points out to our own PC because the training simulator is running locally. We then select the communication driver, New Child, Drivers, and we can see an extensive list of built-in drivers covering the most popular industrial protocols, field devices, and PLCs. All of these drivers are available by default, and their communication settings are fully documented in the VTScada help system. For this project, we select Modbus-compatible device as our driver. We name it Communication Channel. In the Options tab, we simply enable Modbus TCP. No further configuration is required, the port is already linked automatically, we click Apply and OK. Next, we create another context tag to act as a folder, we name it Pump1 and add primary pump as a description. At this stage, all of the tags we have created are internal. We are now ready to create our first external tag under Pump1. We choose New Child, I/O and Calculations, one of the most commonly used tag categories in VTScada. This will be our first digital tag, which we name Running. It represents the operating status of the pump. The data type is digital, meaning the value is either on or off, and we select the equipment type Pump, which is offered by default. In the I/O tab, we specify the read address. Since the data comes from the training simulator, we know the address as 3. We simply enter 3, apply, and OK. Our first digital tag, Running, is now live. In the tag browser, we can immediately see its current value, showing stopped. That's curious, right? With our first tag created, it's time to bring it to life visually. Right-click, Draw, we open Idea Studio, VTScada's powerful and intuitive design environment. Here, we are presented with a library of widget folders that can represent digital tags. Let's select Equipment, Pumps, and simply drag any pump symbol we like onto the screen. A quick layout cleanup is always a good idea. VTScada gives us full freedom to organize and arrange the graphical interface exactly the way we want. On the left side, we see the widget library, which contains pre-configured visual components that can be reused across the entire project. We open the Text folder and select the I/O multi-text widget. We place it below the pump symbol and link it to the same digital tag we just created, Running. Select and OK. Of course, the appearance can be fully customized. Font, size, colors, and many other properties can be adjusted. As this tag is coming from the training simulator, its state automatically switches between on and off. But where do the colors and text labels by these states come from? Remember, when we created the tag, we selected Pump in the equipment type. To see what this means in practice, we can open the system-style tag located in the root directory. In its final tab, called Equipment, you can find the attributes that define the default labels and colors associated with which equipment type. These settings can be easily edited, and you can even create your own custom equipment types with unique labels and color schemes. This helps very much in standardization of your entire application. What could be better than a digital tag? Only analog one. Let's create it. Right-click on Communication Channel, New Child, I/O and Calculations, just as before, but this time we choose an analog tag. We name it Level and assign the corresponding address from the training simulator. We could configure many parameters here, such as a scan interval and deadband, but for now we focus on the Scaling tab and define a scale that better represents our analog value. On the Logging tab, we can see that all tags are historized by default, and we can easily adjust the logging interval or deadband if required. Finally, on the last tab, we set the engineering units to inches. Tag created, let's visualize it. we have several display options available. Let's go with a simple gauge. From the panel of widgets, in the tags folder, we also add a numeric value widget. After opening its properties, we link it to the same level tag. Of course, VTScada provides many other widgets that can represent exactly the same value. Now, let's take a look at one of the more advanced options. Under the high-performance widgets, we select the analog bar. From Tools, Meter Parts, we add a linear scale and a legend. In the widget properties, we invert the direction and link the widget to the same level tag. This widget offers a wide range of advanced features. For example, we can ask it to display the last 2 minutes of operation and indicate the trend direction compared to 2 minutes ago. So, we see now this blue section as level value over the last 2 minutes, while the downward arrow indicates that, even though the value is currently increasing, it is still lower than it was 2 minutes ago. So, we are no longer displaying just a value, we are providing a trend and a meaningful operational context. We can also define an expected operating range and highlight it with a different color to give the operator even more context. What we are creating here is a true high-performance visualization, fully aligned with the modern concept of situational awareness. As you know, traditional HMI designs focused on showing as many colors and details as possible. In contrast, situational awareness concept focuses on improving perception and operator reaction by delivering clear, meaningful information and the right context at the right time. As a result, VTScada provides great tools to design modern, situational awareness-driven HMIs. By the way, dealing with tags, when we need to reduce the number of them, we could always delete them or, in more clever way, just disable with a click. When tag is disabled, it's not counted towards the license size, but it's still there and could be reactivated any moment. Of course, SCADA is not only about monitoring, it's also about control. So let's add a few digital control tags to operate our pump. First tag would be pump start, which will write a command to the appropriate register in the training simulator. Again, new child, ion calculations, we create a second digital tag called pump stop, using a different address to stop the pump. In the Idea Studio, under the Analog Controls folder, we select the Set Value button widget and place it beneath the pump symbol. Open Properties, link it to the pump start tag, set the value to be written to 1, and define the button label as Start. To create the Stop command, we simply duplicate the button and place it next to the first one. We then reconnect it to the pump stop tag and update the label accordingly. In the operator view, we can immediately test the result. When we press Start, the pump changes its status to running and the color switches to green. When we press Stop, just a tiny delay, and the pump stops. That's how control works. With the controls for pump 1 in place, how can we do the same setup for additional pumps? From a graphical perspective, it's very simple. We just select all elements, copy and paste them, and rename the labels. But what about the tags? Of course, we could open Tag Browser, copy pump 1 tags and edit them manually. However, VTScada offers a much more efficient approach. In application configuration, we open Export Sync Tags. From here, we can export all tags to an Excel file in just a few seconds. As you see, the file contains several sheets with all tags and their settings, allowing us to add, delete or edit them easily. First, we create a copy of the pump1 context tag. The key point is to leave the first column blank, because VTScada will automatically assign its own internal name. We then change the name to pump2 and update the description. On the ion calculation sheet, we repeat the same process. Copy the pump1 tags, leave the internal name empty, change the tag names, and update the addresses so they match pump2 in the simulator. In our case, the address offset between pump1 and pump2 is 20, so all pump2 addresses become 20-something. Once the edits are complete, we save the file and synchronize it back into VTScada. In a few seconds, the new tags are created. We can immediately verify this in tag browser where new pump2 tags and addresses appear. The final step is to link the new tags to pump2 graphics. The easiest way is to select all pump2 objects on the screen. A panel opens on the right showing all tags in the selection. Using the search and replace function, we simply replace the pump1 tag references with pump2. Now we can test the result. When we press the pump2 start button, the pump2 tags become active, while pump1 continues to operate independently, exactly as expected. This is an efficient method for creating multiple instances of the same equipment. But what if we need dozens or even hundreds of similar objects? That's where an even more powerful approach comes in. Let's move into a more advanced mode and create pump controls using dedicated widgets and parameterized pages. For now, we delete pump2 because we are going to recreate it using a custom type. To do it, we open the pump1 context tag and assign a new custom type, which we call generic pump. In its properties, we define address offset called adder offset. For pump1, this value is set to 0 because there is no address shift. Next, we modify all pump1 tag addresses and turn them into expressions. In our case, each address becomes the sum of the new adder offset property and the original address. You can immediately see the address fields change color to blue, indicating they are now calculated values. At this point, the tags and their addresses remain the same, but their structure is different. We finalize the change defining the type we just created. Right-click and select Create New Type. We can now create other objects of this type. At the same level as pump1, we add a new child and select Generic Pump from the list. This becomes our new pump2. As we know, pump2 addresses use an offset of 20, so we simply enter 20 for the address offset property, and pump2 is created instantly, with all tag addresses shifted accordingly. But this is just the beginning. Now we want to draw the controls using a dedicated pop-up page. We create a new page called Pump Controls. By default, the pop-up size automatically adjusts to its content, but we can also define a minimum size if needed. We then group the basic pump control elements into a single widget. As soon as we do this, the new widget becomes part of our widget library and can be reused. The most powerful way to use the pump control page is to make it parameterized. In the page properties, we select Manage, Add New Parameter, and create a parameter called Pump Choice. No matter how many pumps exist in the application, we will use the single page for all of them. We link our widget to this parameter, and the pump controls page becomes fully parameterized. Let's see how this works in practice. We remove the graphics we no longer need and place a simple page button on the screen. We name it Pump1 and link it to the pump controls page. When prompted to select the parameter, we choose Pump1. We then copy this button and place it below, rename it Pump2, and assign the parameter to Pump2. In operator mode, we can now press the Pump1 and Pump2 buttons and see two different instances of the same control page, each connected to its own pump. Both pumps are controlled independently. To make it even clearer for operator, we return to the pump controls page and add a text field with an expression that displays the active pump based on the parameter value. We immediately test it and confirm that the correct pump name is shown. One of the greatest advantages of this object-oriented approach is that any change of the type is automatically applied to all instances. For example, if you add an analog clock to the corner of the widget, even if just for demonstration purposes, it instantly appears on every pump control page. This provides a high level of flexibility and efficiency for large-scale application development. Let's take a quick look at the security settings in VTScada. We enable security using the icon in the top right corner, which opens dialog window. In VTScada, users have different roles and privileges, giving you full control over who can access which function of the application. Let's create our first user and call him GRU. As a superhero, he naturally becomes a super user with full control over the application. We can immediately verify that he has almost all available privileges. When we log out and log back as GRU, we see that all pages and all controls are accessible for him. Since GRU is famous for having many minions, let's create another user called Minion. Let's just check first what happens if we don't assign him any role, as there is no privilege that he could enjoy. When we log in as Minion, we cannot open the alarm page or operate any controls, because this user has no assigned permissions. Now, let's give Minion a bit more power. We sign in again as administrator, select the Minion account, and assign him the operator role. As we see, this role provides access to alarm-related functions and control outputs. By the way, using the Custom Privileges panel on the right, we can define very specific access rights, for example, to selected pages or even individual variables. Okay, let's see how the operator role works for Minion. As you can see, the Idea Studio and Tag Browser icons are no longer available, so Minion cannot edit pages or tags. However, he can open the pump controls page and operate the pumps. And he can also access the alarm page, which is still empty because we have not created any alarms yet. So let's fix that next. We open the alarm page by clicking the bell icon in the top right corner, but it's still empty. Let's activate a few alarms using our analog tag. We open the properties on the level tag. On the Alarms tab, we see the standard alarm configuration layout with multiple alarm levels. We configure a high alarm with a set point of 40 and a second alarm with warning priority and a set point of 10. Under the Advanced section, there are additional options such as alarm delay, deadband, sound, database settings, suppression, but for now we will keep the two basic alarms we have just created. Immediately after applying the settings, an alarm is generated because the current level is already higher than 40. We click the blinking bell icon to open alarm page. As we can see, there is an active alarm linked to the level tag, showing a high status at the exact time when the value crossed the set point and the value is still increasing. We can acknowledge this alarm. Once acknowledged, it disappears from the current alarm view, but remains permanently available in the history list. Shortly after, a second alarm appears, the level low alarm. We can click on it to view its configuration and additional information, including statistics. These are all alarms linked to the analog tags. We can also create alarms for digital tags. Let's open the properties of the pump tag, running, and on the Alarm tab, select the Notice priority and choose an alarm condition on Change. After clicking Apply and OK, an alarm will be generated every time pump 1 changes its state, either to running or to stopped. Let's check this on the alarm page. you can immediately see that alarms with different priorities are displayed using different colors. We could check system alarm database only, or menu called the unacknowledged alarms and acknowledged alarms directly from this page. All acknowledgement actions are also logged in the alarm database. The alarm page provides several powerful analysis tools. Of course, we can filter alarms, but also generate alarm reports and review statistics, including how alarms' priorities are distributed. The Bad Actors tab sorts alarms by frequency, helping us quickly identify the most recurring and potentially problematic events. This is a built-in system page, created according to the standard and not intended to be modified. However, we can easily create our own customized alarm displays. In Idea Studio, under Tools, Alarm Tools, we find a collection of alarm widgets. When we add an alarm list widget, we gain full control over which columns are shown, how rows are displayed, and how colors are applied, allowing us to design compact, purpose-built alarm lists or even multiple tailored views for different users. The last two letters in SCADA stand for data acquisition, and VTScada delivers this capability with exceptional efficiency. VTScada features its own built-in data storage system designed for speed and scalability. By default, all information is stored in the data folder of your application, ensuring immediate access. Advanced configuration options are available through the System Historian tag in the root directory, where you can customize storage type and location. Refer to online help for detailed guidance. VTScada preserves data indefinitely by default, unless it is set up otherwise. Alarm Historian is managed separately through the System Alarm Historian, as it is better not to mix alarm history with process I/O data. Accessing historical data in VTScada is fast and intuitive. Simply click any widget representing process input to open the historical data viewer with dynamic trend graph. For example, the level tag can be displayed over the last 12 hours or easily adjusted for a shorter period, such as 2 hours, for focused analysis. I just added another graph called Level 2 that is just one half of Level 1. Each curve is shown in distinct color. Pen properties, including color, style, thickness, and scale, can be fully customized for clear visualization. If we want to add another graph, we simply click on any widget to add it to the same data viewer. We can even click on a digital widget, such as a pump, to display its status on or off on the screen. Okay, let's make it bigger. 2 hours is our current time span. The viewer displays minimum and maximum values for analog values, along with numbers of starts for pump 1. Selecting any pen, we could put momentary values of the screen for detailed analysis. Graphs can be separated, repositioned, or adjusted vertically for better clarity. VTScada also offers exceptional flexibility in time navigation from seconds to weeks or even to 5 years. Of course, we don't have any data coming so far in history, but the readiness of VTScada to momentarily retrieve data archive of such depths is sensational and unprecedented. The historical data viewer can also be opened as a dedicated system page, where users can create and save custom queries combining multiple tags. Let's call it levels. The Grid tab displays precise numerical values for selected time ranges, and user can define sampling frequency as needed. Exporting data is seamless using the Export wizard, allowing immediate transfer, for example, for Excel, for reporting and analysis. Exported files include Unix timestamps, seconds since January 1st, 1970, along with the tag values for level and level 2. This is data we can work with. Finally, let me add a page in Idea Studio, simply called Page 1. Under Analytics, Trend and Historical Data folder, there are several widgets for data visualization. Let's place some of them on the page. Spark lines are compact miniature charts without axes designed to quickly show the shape of trend. The Plot Data widget displays a single selected tag over a defined time interval. The Open HDV widget allows us to open a saved query, for example, the one we have created just called levels, which we can easily select here. Let's see how these widgets work. With the last one, the Historical Data viewer, the operator can independently select which tag or data query to display along with desired time span. This provides great flexibility for every user. And now, a VTScada feature that impresses both users and industry experts the most. Automatic hot backup failover and redundancy with multiple servers is available out of the box and configured in seconds. For critical applications where performance and reliability are key factors, VTScada stands out as a true industry leader. Let's see how it works in practice. To demonstrate redundancy in action, I installed VTScada on a second PC, shown on the right side of the split screen. The first step is to define the client-server structure, and you will be amazed on how simple it is. In application configuration, we confirm the name of our workstation 108, then open Edit Server Lists and add it to the list. The first server listed becomes the primary. My second workstation 213 is added next, automatically becoming the backup server. Click Apply and the redundancy is fully configured. No additional steps are required. Now, we deploy the application to the second workstation. Select Add New Application, Advanced, Get from Workstation, choose Opus from the list and click Finish. A password is required and, fortunately, I did not forget it. The application launches, becoming shared across both workstations. Once signed in, we see the same application interface, fully editable from either workstation. Let me add a square, and I prefer a lighter color. The moment Idea Studio is closed, the change becomes part of application and is immediately synchronized across both servers. Now let's observe failover in action. In the folder of System Pages, there is a page called Services. Let me arrange it for a better view. So, Workstation 108, the PC on your left side, is the primary server, and 213 is the backup. Now I stop the application on Workstation 108. As you see, 213 instantly takes over when the primary server goes offline. All services are now running on the backup server and are marked with a star. As a result, there is no downtime in operation. Now, I will restart my 108 workstation. While it's starting up, services automatically switch back to it one by one. Finally, control is fully restored and services are once again running on primary server 108. If you want to change server priority, it's enough to open Edit Server Lists, select Workstation 213 and move it up to the top. Apply and 213 instantly becomes the primary server, taking control of all services. Have you ever seen any other SCADA systems that can do it so easily? I haven't. VTScada also supports multiple backup servers. Simply add another workstation to the server lists. Whether 2, 3 or more, there are no practical limitations. What's more, in advanced mode, servers can even be assigned as primary for specific services and backup for others, enabling smart load balancing across the network. The result is a redundancy solution that is powerful, flexible, and remarkably easy to manage, exactly what modern critical systems demand. To conclude this introduction on a high note, let me show you a powerful feature that wins over every developer working with VTScada: advanced version control. This advanced capability is included with every runtime license. To see it in action, let's add a simple object, for example a square shape in Idea Studio. I'll select a blue fill color. Once the action is complete, we open Application Configuration, Show Version Log. Here we see our application presented as a log of all changes made during development. It provides full traceability, allowing us to see what was changed, when it happened, and who made the change, simply by moving up and down through the list of records. Let's review the most recent update. Right-click, Show Version Details, and the highlighted record reveals the exact source code modification, showing the graphical element added to the page. If we don't need it anymore, we can delete it right here by pressing Reverse Version Change. As you see, the square is gone. Restoring it is just as easy. We can reverse the removal or switch directly to the earlier version where the square was created. After pressing Apply, the object immediately returns. But this is more than a simple undo action, as this change also becomes part of the application version history. We can go as far back as needed and switch to an earlier version, when no security accounts existed, when actually nothing had been created and the tag browser was empty. Afterwards, we can simply return to the latest working version and security accounts are restored, and all we need is to log in again. With application version control, you can confidently recover from unwanted changes, compare versions, and even merge changes from different versions. This is an incredibly capable built-in feature that makes VTScada stand out from other SCADA platforms. Finally, let's create a change set file. Since your project is stored as a series of changes, VTScada can generate an optimized file for easy distribution. You can create a snapshot version without development history or a full change set file with complete traceability. Click Create and your application is instantly ready to share in a very compact format. Please share it with us. I am confident that after this brief introduction, you will be eager to explore more of VTScada and its exceptional capabilities. Visit VTScada.com and navigate to Resources, SCADA Video Tutorials, where you will find a rich library of videos covering license management, core application features, and connectivity with the most popular protocols and field devices. Want to discover even more? Visit the VTScada by Trahedral YouTube channel, where dozens of videos are available, from practical tips and tricks to advanced technical deep dives. And the best way to experience VTScada is to try it yourself. At VTScada.com you can download the free VTScada Lite version. While limited to 50 external tags, it is completely functioning with all drivers, alarms and historian. Simply click VTScada Lite, complete a short form, and begin the software adventure of your lifetime.